Hello people, this is the review recording for the calculating power section right here. If you're not on that one, go find a different video. Alright, so I'm going to do number 5 and number 6. Number 5 says Mr. McSparron has a mass of 90 kilograms. I'm just going to go ahead and put a box around that right now and label that as M for mass. Okay, he walks up a flight of stairs in 3.6 seconds. I'm going to go ahead and put a box around that. And I'm going to put an S for, ooh, wait, no, screw, no, don't do it. Put a T for time. Okay, if the stairs are 5 meters tall, I'm going to go ahead and put a box around that. And you guessed it, that's going to be a Y for height. What is Mr. McSparron's power? Okay, so I know that I've got mass of 90 kilograms. I've got a height of 5 meters, and I've got a time. Uh-oh, hang on. Oh no, multitasking gestures interfering with writing. Okay, I've got a time of, what did it say? 3.6 seconds. Okay, now what we need to do is remember that power is going to be work over time. In this case, because this is just a simple old lifting something up, work is going to be EG. So to calculate EG, I'm going to have to do M times G times Y. Okay, now M, we said, was 90. All right, so I've got 90 times, now G is always 9.8, and then multiply times Y, which we said is 5. Okay? So I've got 90 times 9.8 times 5. Let's do, come on, calculator, open. 90 times 9.8 times 5. 4410. Okay, so I've got 4410, and now I'm going to divide that by time. Remember, I have to divide by time, and I said that my time is 3.6 seconds. So let's go over here, and I'll put 3.6 there. So 4410 divided by 3.6 is going to be 1225. Okay. 1225. And remember that we're going to write that down in watts. Okay. So there's number 5. There's the whole view. If you have a question about that, make sure that you ask me when you do number 7. It'll be similar to number 5. Okay, number 6. After climbing the flight of stairs, Mr. McSparron picks up a heavy box and climbs a second identical flight of stairs in the same amount of time. Compare his power on the second flight to his power on the first flight. Okay, so let's think about this. So what we're saying here is that Mr. McSparron, he did this first flight, just him. And then he does the second flight, okay? But now it's, oops. Now it's him carrying a box, okay? Well, if he does it in the same amount of time and it's the same height, everything is the same except for one thing. So what's different now? Mass. And in particular, mass increased. Okay, so if we go look at our equation here, okay, if I were to make this number bigger, it would make the amount of work bigger, which would also make power bigger. Okay? So my answer for this one, when I say compare his power on the second flight, so it says compare his power on the second flight to his power on the first flight, okay, I'm going to say something like, Mr. McSparren has more power on the first flight than the second flight. Whoa, 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 whoa. We gotta flip that. Holy cow. The second flight has more power. Okay, he has more power on the second flight than the first flight. Jeez Louise, guys. That almost got bad. So there's my answer. Sorry that got sloppy. Mr. McSparren has more power on the second flight than the first flight. And that really makes sense, okay? Because if we think about, like, which guy, like, which one of these guys is more powerful, well, the guy that can run up the stairs in the same amount of time with a heavy box is more powerful than the guy with no box. So really that, like, common sense-wise, that makes perfect sense here. Okay, again, if you have any questions, make sure that you're asking me right now.